Introducing the new DigiCert. As the leading provider of high-assurance SSL, TLS, and PKI certificates, DigiCert is all about improving security across the web and IoT. DigiCert is committed to helping customers and partners successfully deploy identity, authentication, and encryption solutions. They'll even help you figure out which certificate you need to secure your web domains, apps, devices, and more. Check out the Cert Wizard tool under the SSL tab on digicert.com. The average time between being hacked and realizing you've been hacked is 1 year. Can you afford to let an intruder roam your network for that long? Can your company weather the fallout when this comes to light? Black Hills Information Security can find the bad guys in your network and train you to do it yourself. Email consulting@blackhillsinfosec.com to find out how a hunt teaming engagement can help you find a persistent threat in your network. Signal Sciences is the industry's first web protection platform that works in any cloud, any container, any platform as a service, and any modern application architecture. The Signal Sciences web protection platform can be deployed in next-generation WAF, RASP, or reverse proxy modes, giving customers ultimate flexibility and coverage. Protect your web applications with Signal Sciences web protection platform. Signal Sciences, protecting applications, connecting teams. For more information, check them out at signalsciences.com/PSW. Welcome back, everyone, to Paul's Security Weekly. Still drinking wine, having a cigar. Now I'm going to kick back because Joff, he's got a serious hat on. He's about to deliver a technical segment. We don't know what the technical segment is going to be, but we're very anxious to find out, Joff.
Okay. So I'm going to attempt to deliver a technical segment. Now, I will warn you, there's been some serious Bombay Sapphire going down, so please don't use anything against me that I say here, or something like that. I don't know what the appropriate disclaimer is. Anyway, I'm going to attempt to share some windows here. Hold on a second.
You mean share your screen? Share your
share the screen.
Right.
Where's my button? Share screen. Go. All right, and we're going to switch over to some PowerPoint really quick. I'll try not to do death by PowerPoint too much. Can you see that okay?
Yeah, and a big phone on the screen, too.
And a big phone on the screen. Yeah, that's an Android, believe it or not. We're going to talk about the Android in a minute. I'll slide that off to the side. All right, so we're going to talk about some Android APK testing fun. So, it's occurred to me lately that way too many of us are not talking about mobile yet. We have customers that we work with who are very astute customers and are doing their best to defend their enterprises. But in many cases, they're ignoring the mobile threat. And
now, Joff, I want to chime in right here because it's an issue that's kind of near and dear to my heart. Android is not necessarily a phone either. It's embedded in a lot of other devices, and I think even more so than like mobile security that we're not talking about. Even further, we're not talking about the security of other Android-based devices where sometimes it's not even apparent that it's Android under the covers.
That's exactly right. The Android is embedded in a lot of things, tablets, phones, embedded devices, and so forth. So,
well, yeah, and personally, it's a high-end like audiophile music player that runs Android. It's also, I have 3 NVIDIA Shield devices in my house that recently are undergoing an update. There's an update available. I upgraded one of them. And in that update, not only does it include a tremendous amount of functional and user updates for the end user, but also includes Android security updates as part of that as well, which I'm kind of cringing that I have to update to get the fixes, and I don't necessarily want to take the plunge into an entirely new user interface now, but I'm going to nonetheless.
Well, sometimes you got to bite the bullet, right?
Mm-hmm.
Given that, and Paul's exactly right, I decided to focus a presentation on Android, specifically on Android application packages, and a little bit of testing around them, because I've been doing some work in this area lately. Now, I'm not deliberately trying to exclude Apple iOS. I think Apple iOS is a fine operating system, but it's quite a different entity. When you look at the Apple iOS ecosystem, I hate using that word ecosystem, but I will. We've got the 5 guys in a cave phenomenon happening there. And by that, I mean, there literally is guards on the App Store whose sole job is to vet the applications And the ecosystem is quite closed and it's quite different from the Android space. And many organizations indeed actually choose to exclusively support their enterprise applications only using Apple iOS. We could get into a philosophical debate here, but I think that the utility of that is going to be limited long term. Android is a massive force, and the fact that it is an open ecosystem, it is an open playing ground, is giving it a tremendous amount of traction in the market. But I don't want to talk about the market forces today. I'd like to talk about a little bit of Android penetration testing fun, and just do, like I have on the title here, a quick and dirty presentation on some of the techniques that we would use to test mobile applications. And advancing the slide did not work. Okay, let's try again. First of all, must-have tools. So many of you are probably aware that Android runs a bytecode compiled version of the apps. For all of the various apps that you might install on your phone. They're in a DEX format. DEX is actually quite reversible and can be decompiled into what resembles very, very closely Android original source code. Not exactly, but it's pretty darn close. And so JADX GUI is a very important tool to have to reverse the source and actually be able to look at the APKs directly themselves. The other thing that's incredibly important to have as a penetration tester for Android penetration testing is Android Studio and the Android emulator itself. And you've already seen the emulator because it's hidden off to the side of my screen here, sitting here running a Pixel 2 emulation on Android 8.1 because I'm going to attempt to do some demos in a little bit. Okay, so I'll slide that back off to the side again. The other tools that I think are really important to have, one is a very, very pointed, distinct kind of tool here called AXML Printer 2, which is a tool in enabling you to convert the Android binary manifest format into a text-readable manifest format. And that's actually an important thing to be able to do because the Android manifest is a very important component of any application deployment for us to be able to look more deeply into what that component is, what that application is actually doing. And we'll get into that in just a minute. Another tool that's really critically important is Drozer. Drozer is a way to look at Android internals, and Drozer consists of an Android agent that you run on your emulator or your rooted phone, as well as a command line console that you can connect into the Android with. And I guess the last thing in terms of the key components that I'd mention is perhaps having yourself an Android platform that is actually rooted. The Motorola Nexus 6 platform is one that's very useful because that is quite easily rooted, and it also runs the Google versions of Android. Nexus 6 was big. I think you had one, didn't you, Paul? You had the Nexus 6 in the day when it came out?
Is it a Nexus 6 or a Nexus 7? I don't remember which.
Yeah, you probably have the 6 or the 7. It's fairly large screen, nice platform.
I think I might have gone from a 6 to a 7 to a Pixel to a regular Pixel, and now I have the Pixel,
Pixel
2. I have the Pixel 2 XL currently today. And
Exactly.
Next will either be the next iteration of Pixel or maybe a OnePlus 6. I'm not sure. I like the OnePlus stuff. I've been reading about it.
Absolutely. And I've got a Pixel 2 right now, but I also have in my testing kit a Motorola Nexus 6 platform, which is very, very easily rooted. There's some nice root kits out there to give you the root access. And having root access to the file system is actually pretty important for your testing methodology. So without further ado, we'll try to advance a slide here. Let's have a quick look at market share just before I get into some of the testing quick and dirty stuff. It's important to realize as a penetration tester, if you're looking at mobile APKs, mobile device testing on Androids, that you're in a world where the majority of Android operating systems right now are still somewhere between the Marshmallow 6.0 release and the Nougat 7.0 release, which is actually behind the current state of Google. Google
And,
is sitting
Joff, is this just smartphones, or does this encompass all Android-based devices?
As far as I know, this slide actually encompasses all Android devices.
Okay.
Well, at least all mobile and tablet. If you see in the title there, it says mobile and tablet.
Okay.
Android version market share worldwide up to May 2018.
Yeah, and like I said, being a super tech nerd, I find Android on a lot of other devices other than a mobile like a phone or a tablet as well. More and more so today than before.
Absolutely. You're going to see, there are even platforms like the Odroid and some of these other portable testing platforms, portable ARM-based processor platforms will totally run Android, right? And you're going to see a lot of embedded devices take off with this, and that's increasing because of that open marketplace approach that Google is taking with the Android operating system. So now, if you look at this slide, you look over at the red line here, which is slowly declining. That's the 6.0 Marshmallow trend, and then you look at the 7.0 Nougat trend. Those things are about meeting here in May 2018, and I believe 7.0 is probably, if we were to extrapolate out using our good old-fashioned statistical regular expression skills, regular expression, what do I mean? I mean linear analysis skills, we would determine probably fairly conclusively that Nougat's probably taking over. The reason I show this slide is that it's really important as a pen tester to mimic the appropriate version of the Android operating system with the app that you're testing that has the global market share, because that is the greatest risk that you're going to deal with, and it's important to actually play in that sandbox when you're testing your app. So what are the other steps we need to take here? Well, the first thing we need to do is configure the emulator. Now, there are multiple choices here. There is even an emulator for Android that runs as a VMware image for VMware Workstation or VMware Fusion, whatever your VMware product of choice is. There's also Android emulators that run within Android Studio. These are the ones that I prefer to use, and once you have installed Studio, and I'm going to gloss over those details because we really don't have time, but once you've installed Studio, bring down the Android APIs anywhere from 6.0 all the way up to 8.1, which is encompassing the major market share, you can then launch your emulator, which I'm showing here, which gives you a full Android operating system on your platform of choice. In my case, this is OS X, that you can actually test with. Now, there's a couple of caveats here that you need to be aware of. One of those is, and this is a road I went down early on, if you decide that your testing platform is going to be a virtual machine, as in a full Ubuntu virtual machine or operating system of choice, and then you want to configure an Android emulator within that virtual machine, one of the things you're going to run into very, very quickly is that the Android emulator requires some graphics acceleration. And so it requires some visibility into the host operating system. And in the world of VMware Fusion or VMware Workstation, that becomes a little bit more difficult. There are knobs and dials that you can turn to get you that kind of access. But what I've found in general, when configuring Android Studio and configuring the associated emulator, it is much simpler to do it on a host operating system that is running on the actual hardware itself, so that the emulator has the graphics acceleration abilities made available to it directly. The next trick is finding your package file, right? If you're in a pen test contract, more than likely your customer has probably given you some sort of APK package file, which is the Android package file format. Now, interestingly, an APK file in Android world is simply a zip file. You can unzip the thing, and it gives you the binary format of all of the various components of that particular application. You can unzip it on any file system of choice. In my case, it's Mac OS X, and I can show you the unzipped version, all the different components, right? If you decide not to get the APK from your customer, there are options available to you. For example, you can go to apkmonk.com and download Android APK files directly Now, the Play Store doesn't make this available to you because the Play Store is designed to download the binary version directly to your phone and install it. But what we're talking about here is wow, Jin talking here. What we're talking about here is actually downloading the binary APK zip file so that you can analyze it outside of the Android device itself, and that you can sideload it potentially into an emulator or a rooted Android device. So you need an alternative source other than the App Store to do that. I find that APK Monk is very, very useful. There's also another one called APK Mirror. I'm sure there are many others available to you. The next trick is sideloading your APK into the Android device itself. Now, this is where the Android debugger is very, very useful, and it assumes that you have gone through the process of fully setting up Android Studio on your platform. So using the ADB install from the command line allows us to sideload the app directly into our emulator or other rooted device, right? So if we were to take a command line here really quick, right, and let's do a quick ADB devices, for example, I can see that my emulator device is listed here under the devices list. I can even create a shell on the emulator device using ADB shell, and I can see that I'm talking to the Android file system, which is actually a modified Linux kernel. So this is me actually using the ADB shell and talking directly to this emulator that's over here to the right of the screen, and I'm actually directly interacting like a Linux shell, right?
And now, Joff, we covered some articles recently on this. Tablets and phones kind of aside, a lot of folks will enable the Android debugger and allow third-party packages to be installed that aren't signed in order to sideload entertainment apps such as Kodi on their various devices, common on the Amazon Fire TV platform, common on a lot of other platforms as well. And a lot of times what I think people will end up doing is just leaving that setting enabled and not going back and disabling after they installed what they needed to install. I think we're seeing a large, from what I've been reading, a large number of devices that have this enabled.
Yeah, absolutely. And it's actually a dangerous practice because when you if you attach your phone to a USB cable and you enable debugging mode and enable sideloading, essentially what you're enabling there is the ability to use ADB install, this exact command, to sideload an APK package directly to your phone. And
there's no authentication associated with that protocol. In other words, when I enable it and I allow unsigned packages, I can put another app on my phone, for example, and that's how people are putting like Kodi on their devices. And there's no authentication in that process, which is terrible.
No, absolutely not. In fact, I can even show you. Let's see if I have my APK file that I'm going to use here, which is a Compass app. I literally downloaded this from APK Monk, okay? And I can do ADB install. If I could actually type, that's the Jin talking again, right? I can install this APK file. There's no authentication at all. ADB is directly communicating with the device and telling me that it's already installed. Well, I'd have to uninstall it. Let's go ahead and uninstall it just for fun. Come on, Android. Let's go. Okay, this is where demo hell gets me. Well, we'll just skip that. But if it wasn't installed, it would just go ahead and install it. You just have to trust me on that. Because apparently I don't know how to uninstall the app right now. Let's see. Maybe I can work it out. Let's see. Compass. Drag. Uninstall. There we go. All right. I just uninstalled it on my emulator, which is just like using your phone. And I can reinstall it with ADB install. And no authentication, talks to the device, and just installs that APK, sideloading immediately, okay? Now, of course, that's not a real phone. That's an emulator, but there is really no difference on the emulator for the real phone, okay? So ADB is your friend is the first message to the pen testers, right? You've got, Courier font rocks, by the way. I don't know why. I was just in a mood when I wrote this slide, right?
You're drinking gin. It's fine.
Yeah. ADB devices to list the devices, ADB root to make sure you're running in root privilege mode, ADB shell to actually get a shell on the device, ADB push to push files to the device, ADB pull to pull them back, and then, of course, ADB install that you just saw to actually install an Android APK. Right? Now, once you get this installed, you could go into ADB shell, for example. Most of your apps live in data/data directory. And when you look at this, it's convincently Compass, you'll see that there is a directory for all of the code belonging to this Compass app. And that directory has a cache and a code cache and some libs and everything else, right? This is the full binary version of the app itself. Now, once you've got that, you could perhaps decide, I'm going to go into my diffs directory real quick here. You could perhaps decide, hey, I've just installed an app. Maybe I want to pull down the pristine version of the app from the device so that I can do a diff between the first time run and the installation image. And so to do that, you can actually pull down that complete directory. And you can see here, I've got an image of everything that was on the Android using ADB pull. Okay, that's actually kind of fascinating, because if you were to go over to the Android here, pull up your menu, run the Compass app. Okay, this is the app I just installed. Now it's running, and then I do ADB pull again. Okay, and I give it another directory name. Okay. And then I can do a binary diff between the original one I pulled and that one, and I can see exactly which files get created upon the first application run. Okay, so even that, at that level, becomes kind of interesting, right? You can see immediately what this thing is doing on the file system, and then you could go back into your ADB shell, and you can go investigating those things, right? com.vincent.compass. Okay, what is this? What is this databases directory? That's always fun, right? By the way, this is the very first time I've looked at this app. So we're doing this green and vanilla. Hey, we've got Google Analytics DB there. So we could go into SQLite 3, Google Analytics.db, and we could look at the schema, right? And we could see it's creating some data here, right? And we could like select things from hits too, right? So we can immediately do some analysis directly on the phone. There's nothing in there right now because I obviously haven't done anything interesting, right? So there's already some interesting things there. Now let's go a little further, okay? First of all, what's your intention? This is a pun, right? Let's move the jiggling compass out of the way. An Android intent is a messaging object used for many, many things. Think of it as the universal inter-process communication mechanism for Android, okay? What do I mean by that? Well, we can use an intent to start an activity. We can use it to start a service. We can use it to deliver a broadcast message. Android apps, in fact, live and breathe in a sharing and loving community on the platform. You like the way I put that? Sharing and loving community, right? Well, what do I mean by that? Well, if we start an activity with an intent in the world of Android, we can actually completely start an app from scratch as if it had never been started on the phone using a third-party app. Whoa, how is that even possible?
Wait, so is this like you loved apps so much that we put an app inside of your app?
Yeah, it's almost like that, right? There's an inter-process communication mechanism that communicates between all apps in the Android, and it's called the intent mechanism. And you can use intents to send messages back and forth across the ecosystem, essentially. Now, when we talk about delivering a broadcast message, we're talking about delivering messages that might be related to, I don't know, things like system events, like the phone just started up, or the phone just was put into airplane mode, or the phone just sent an SMS message, right? Delivering a broadcast message is a more interesting thing that might happen systemically that other apps are interested in subscribing to, for example. Versus starting an activity means actually starting an independent, separate screen that is user interactable on the Android phone that is started potentially by another application. Think about that. Paul, you can probably think of this when you're looking at your SMS application and you want to look up a contact. The SMS application is going to start the Contacts app. That is starting an activity, right? To look up the contact, for example. So intents are interesting because they enable us to share inter-process communications across the whole platform. What about our friend the manifest? I thought this was going to be short and sweet. Sorry, it's not so short and sweet. The manifest file is in all apps. It is required to declare the application name, to declare all the components of the app, includes declaration of all activities, broadcast receivers and services, which we just talked about, declares the various permissions the app needs, and declares the hardware and software features of the app. So we should always look at the manifest file. Let's take a quick look at a manifest file for fun and games. Okay, let's get out of our shell. Let's get out of our diffs directory here. I have extracted com.vincentlee.compass into a directory here. If I cd into that directory, I can see the binary structure of this app. As a part of that binary structure, there is an Android manifest.xml. This is the manifest file. So naturally, being Unix geeks, we just want to do more Android manifest. When we do this, we quickly find out that this is some sort of binary encoding and is not very readable. That's highly annoying. There is a lovely program called, and I mentioned at the beginning, AXML Printer 2, which is a Java file that you can download, which actually will decode the Android manifest and allow you to write it back into a text format. And once we do this, we can look at the manifest in its full text format as it was originally developed. And so this manifest here tells us that we're using the accelerometer. I can't even say that. Accelerometer and the compass, and we're using the hardware location GPS, and we're using internet permissions. We're using network state. That's kind of fascinating. We're using fine location, meaning we have very granular GPS location. We are able to do billing. Wow, that's interesting. Okay. We're able to, well, what else? We don't really have much else. We have various activities and intents advertised here. We have a main activity. Okay. We have a launcher and so forth. Okay. So the Android manifest is interesting. What else is interesting? Well, Drozer. Drozer is a very interesting framework for Android security assessments. It actually consists of an agent that runs on Android and a console running in Unix. It communicates over TCP, and it has various modules to actually examine the app itself. And Drozer allows us to send stimuli to the app as needed. Okay, well, let's look at this. I'm going to pull up Drozer on this Android really quick. This is supposed to be a quick presentation. All right, here's Drozer. It's running, and its embedded server is listening on TCP port 31415. Okay. Now we're going to pull up our server side, and this is my Drozer virtual environment here, and I'm going to do a Drozer console connect with Drozer, and that's how we bring up Drozer. Now, there's one step I missed, and that is forwarding a TCP port. In fact, let me show you that real quick. I had to do ADB forward TCP 31415 to TCP. Wow, Jen talking again here. 31415. What that does is forwards local communications through 127.0.0.1 to the emulator, allowing me to communicate with the agent on 31415. Okay. Once we get into Drozer, we've got some really interesting things. One of the interesting things is the attack surface module that allows us to run app.package.attack_surface, and app.package.attack_surface allows us, I'll use the help here, to specify a package. We're going to specify com.vincentlee.compass, and it gives us a readout of the activities that are exported, the broadcast receivers, the content providers, and the services. And we can see that we have one activity exported from this application. Okay. We can then run app.activity.info on the com.vincentlee.compass app and fail. Okay, you know, live demos are always so much joy here, right? I think I have to do -a com.vincentlee.compass. Okay. And it tells us there's one app here with permissions null, meaning we should be able to launch that activity from Drozer. Okay, permissions null means there's no restrictions here to launching that activity with an intent. Okay, so let's look at activities again. Okay, we can run app.activity.start. Right, this is watch Joff mess up typing. -component com.vincentlee.compass uh-oh. Did everything go blank?
It's back.
It's back. Okay, good. com.vincentlee.compass.main activity, which is this one right here. Okay. And look what happened in the emulator. The compass actually starts, right? Meaning that I can use an intent to actually trigger an application to start. Okay. Now, this applies to activities, it applies to services and broadcast receivers. So I want you to imagine this for a minute. What if a broadcast receiver was implemented which was listening for you to start a debugging process in an Android app? Okay. Now, if that was the case, there happens to be another functionality here called ADB logcat that shows us the Android log, which is basically the syslog, if you like, of the Android device. If I would be able to start an intent that displays debug logging of this app, more than likely that logging would end up in the logcat system log. And if that contained sensitive information, such as HTTP headers, HTTPS information, then we would have a vulnerability in this app. Okay, hopefully everybody's tracking with that. I know Paul's not because he's probably chatting on Slack. But
what? Yeah, Slack. Yeah. Right.
All right, so Drozer's really cool, right? We have these modules to examine the app, and we can send various stimuli to the app as needed and make it do things, which makes application analysis kind of interesting. Now, I picked Vincent Lee's Compass app completely at random, like one or 2 hours ago, okay? So I don't have anything interesting there. What else do we have, though? We have the JADX GUI, which decompiles and deconstructs DEX files into Java source. What do I mean by that? Well, mostly, if we're doing some reversing and we're interested in searching for things, we can decompile the DEX file from the Java app into source and then search for things that are interesting in the source code itself, such as intent communications, such as dangerous network class usage, SMS manager usage, maybe contact address book access, and so on. What are the kind of search terms that you might want to use? Well, you could use getExtra, which is a function call to get extra data from an intent. You could search for putExtra. You could search for action calls, for example, to make a phone call. You could search for getCellLocation, for location manager, maybe process builder, which runs local processes. There's all kinds of things that you can search for in JADX GUI, right? Let's do a little bit of JADX GUI really quick, if I can get it up and running. That's what she said, right? So we're going to say JADX GUI. Now, this looks all really easy, but I have pre-installed lots of stuff on my system to support this. And you need to be aware that there are many installation steps required for Android Studio, not so much for JADX GUI, but certainly to get things like the AXML Printer 2 up and running, and also to make sure JADX is up and running with the appropriate Java version, and also to make sure that Android Studio is running with the appropriate APK. So there's lots of information here that I'm skipping. All right, we're going to run JADX GUI. and hopefully JADX GUI will pop up here. JADX GUI immediately decompiles the whole APK, right, from the DEX bytecode compiled version, and gives us a view of the actual source code, as much as it can ascertain anyway, from the app itself. Okay? Once we have that view, we can do things like a text search, okay, for, I don't know, it's going through a decompilation step here to finish the decompilation, but I'm going to search for Location Manager, which is an attempt to use the APIs that surround the GPS functionality of the device. While we wait for the decompiling to process, you'll need to listen to the music gently in your head. Paul, do you have any questions while we're waiting for the decompilation process?
What kind of music should I be listening to, Joff?
I think you should be listening to some heavy metal right now.
Usually not in my playlist, but okay. Sure.
Let's go with Disturbed. And Disturbed's cover of The Sounds of Silence is one of the best covers I've ever heard, actually.
I've been listening to a lot of old school rap as kind of a tease for potentially what might be a talk that I'll give at an upcoming conference, but we'll see. We'll see.
All right, rock and roll. All right, so I've searched.
No, actually hip hop, but it's okay.
It's a great little segue just to relax everybody into the decompiling process. So once we search for Location Manager, we can actually take a look in the source code by double-clicking on one of the hits, and it will bring up the actual source code where it's using the Location Manager class, and in this case, we can see that it's actually trying to get the get system service location, essentially trying to find the location of the Android itself in GPS coordinates. So this app is already doing things that, may not be desirable. You can decide for yourself. Now, other searches that you might want to search for is things like the socket library, right? Just search for the word socket. Are they using network sockets in this application? Well, it looks like it. Let's go and look in the source. We can see looks like a bunch of commented out. This is the first time I've seen this, so excuse me for that. But looks like they have some sort of method called final void run here, which actually attempted to use a socket, perhaps to write some analytics or status information back to the author's server or something like that, right? So you can get a sense of what's going on. Now, anyway, we're not going to go too deep into that. So in summary, we'll go back to the first slide. If you want to get set up for your Android environment to actually do some analysis in pen testing, get the fundamentals installed. JADX for the decompilation, Android Studio and an emulator on your platform, AXML Printer 2 to extract XML manifests, the full Drozer source to poke around in Android internals, and that is not a lightweight thing to do, by the way. And once you're there, you have enough stuff going to start actually doing penetration testing and reversing of APK files within the Android platform. And that would be the end of my lovely tech segment, which was an awful lot of information packed all together at one time.
Joff, thank you very much. With that, we're going to take a short break, come back with the security news for this week. Stay tuned.